Hello, this is a short little video on providing a subsidy for a public good with the idea that you can enhance the use of a public good through a subsidy. And this video is meant to be a follow-up on the previous video about congestion taxing for dealing with road traffic. In the previous video, we looked at how to set a congestion tax to eliminate the problem of too much traffic on a road. Now, one of the things about setting a congestion tax is you're reducing the number of people who are using a road. And so what are you going to provide as an alternative means of transportation for those people becomes the next question. And the solution for that is to take the money collected by the road tax and use that in order to subsidize mass transportation, so those people who were formerly using the road now have an alternative means of transportation to do things like getting to work and other things that they need to do. So in this situation, we're going to look at a mass transit system, and we're going to start off by considering the quantity and demand for the service provided by the mass transit system and the quantity supplied of the mass transit. And we're actually going to look at, what would we need to do so that the mass transit system can absorb the population that's been displaced by the road tax. So the first thing we need to do is we need to consider, what would be the current price of riding on the mass transit system and how many people are currently riding on the mass transit system. And we're going to do this, it's like any other market that we have looked at before, where we're going to start off with our equilibrium situation, quantity supplied to quantity demand, and we will look at our equations here, right? 300p minus 500 equals 7,000 minus 200p. Right? We've set our quantity supplied and our quantity demand equal to each other. We reorganize this so it will be 500p equals 7,500, and if we do our math correctly, we should come down with a price of $15. In other words, $15 is what people are currently paying to ride this mass transit system. And at a price of $15, how many people are using it? Well, we take our quantity demand and we sub in, right, 7,000 minus 200 times 15 for our price. That should give us 7,000 minus 3,000, or currently there are 4,000 people riding on the mass transit system. We could envision this in a market diagram as looking like this. We have our downward sloping demand curve. We have an upward sloping supply curve. Now I want to talk about the upward sloping supply curve for the transit system. The supply curve for the transit system is different than the supply curve for a road. In the previous problem, the supply curve for a road was perfectly inelastic. That's because the amount of capacity set by the road system has been built, and it's going to be hard to provide additional roads. It's an expensive, time-consuming process. A transit system, however, can change the amount of supply by adjusting the amount of buses in this system, by adjusting the amount of subway carriages and train carriages that are in the system. So it's possible to adjust the quantity here, and of course, the ability to supply buses, the ability to supply more subway cars or train carriages depends on the amount of money that you want to pay. There could be a positive slope to that supply curve. So what we found out is that the current price is $15 and the current quantity is 4,000 riders. However, we had 1,500 riders from the road system in the previous problem that are no longer driving. They have to have another way to get to their destination, and this could be that way. But what this means, it means increasing the amount of riders by 1,500, basically getting that out to 5,500 riders. Now what we need to find out is, right, how much is it going to cost to make that happen? And there's two parts about making that happen that are important. One is we have to figure out the price that will get those riders into the system. How much will it cost so that, how much will those riders pay to ride the transit system? Okay. Also, how much will it cost for the transit system to provide the rides for those people? Right? There is capacity issues here. And so this becomes where we're aiming for, our goal. Now you'll notice that the price here, the price of supply, is there, right? Where our 5,500 riders match the supply curve, that's the price of supplying it, right? The price that consumers want to pay, the price for demand, is down here. This difference between these two, well, this is the amount of subsidy that we're going to need to add to the market to make that happen. So, how much is that going to be? Well, it's actually not that hard to figure out. We can quite simply use our supply and demand curve information to figure out what the price would be at those two different levels. So what we're going to do, we'll do it in two steps. We'll start off with our supply and demand and make that equal to our quantity goal. Our quantity goal is this. Quantity goal is 5,500 riders on the system. Okay, so if we're going to set our quantity demand equal to our quantity goal, that will look like 7,000 minus 200p equals 5,500. Okay, we will then readjust this, right? So we will have 200p equals, we'll bring our 7,000 over, so we will have 1,500, and that will give us a price of $7.50. So the price that riders would be willing to pay to get us to that number of riders is $7.50. Okay. Well, how much is it going to cost to ramp up the mass transit system to be able to accommodate that many riders? Well, we'll use our supply curve for that. And we will set our quantity supply equal to our quantity goal, right? That would be 300p minus 500 equals 5,500, right? Our goal of riders. Do a little bit of algebra again, and we have 300p is equal to 6,000 because we bring the 500 over. And what this is going to do is it's going to give us a price of $20. So the price needed here is $20. So how much should our subsidy be? Well, let me erase this, right? Our subsidy will quite simply be the price necessary for the supply minus the amount that people are going to pay, okay? Which basically comes out to $20, what we have to pay the transit system to support that many riders, minus the amount that the riders are willing to pay, $7.50, which gets us to a subsidy of $12.50. Now, here's the real question. In the previous question, the government collected a road tax. And in the previous question, right, the road congestion tax brought in $69,000. Well, how much will this cost? Well, quite simply, the subsidy in total will have to equal, right, the amount of the subsidy, $12.50 times the number of riders we have, which will be 5,500. Well, if we multiply both of this together, we will get 68,750. So that's the amount of the subsidy. That is the amount of the road tax. And what you can see is, in this case, we can tax the road drivers, get the money necessary to ramp up the transit system. That's how much it will cost to do that. And we can shift the riders, right? We can remove the excess road congestion and put a lot of people into the mass transit system and allow the entire system to work better. And this is a good example of how we can actually use a combination of taxes and subsidies to achieve a functioning public good, a good road system and a good mass transit system.